All right, in this video, we are going to talk some more about this mole, not this mole right here, but the mole in chemistry. And we're going to talk about converting and conversions. And so we're going to review a little bit and then just do a lot of practice problems. I will have some more videos that will just go through problems converting from one unit to another unit. And then I will have some more practice problems that will give us two-step conversions. So let's get started. Okay, so unit conversions. This is where we're using a lot of what in chemistry we call conversion factors. So unit conversions use conversion factors to change a measurement between units. So we're just changing what the unit is. If we start with 1 unit, we're going to change to another unit. And we have to set up the conversion factors to be able to do this. All right, so for example, let's convert 2 feet to inches. Now this is a very simple conversion. It's something you all can relate to, and you know how many inches are in a foot. All right, so we use what we call these T-charts to do these conversions, and it just kind of helps us organize our numbers and know where to put them and where to put the units. So at this time, we're going from 2 feet to inches. So 2 feet is what we're starting with, and that is what we write in this upper left-hand corner right here. Now we let the unit tell us how to set up the next conversion factor. So here we have feet. We're going to put feet down here so they are diagonal from each other. So we put feet down there. Now where are we going? We're going to inches. So we're going to put inches on the top. Okay, so at this point we need to say, well, what is the relationship between inches and a foot? Well, we know that there's 12 inches in 1 foot. So at this point, we can do the math that's involved. And because feet are diagonal from each other, or, feet divided by feet is 1, so we cancel them out. And we end up with inches, which is what we wanted. So now we do the math. You multiply the numerators together, and then you'll multiply the denominators together, and then divide them out. So this ends up being 24 inches because 2 times 12 is 24, and it was just over 1. So 2 feet is equal to 24 inches. What did we do? We changed the unit. The next thing we need to look at is how many significant figures do we have? So we look at what we started with. 2 feet, that's 1 significant figure. So this number has 2 significant figures. So we need to make this number so it only has 1. Now, significant figures is something we did at the beginning of the school year. So maybe a little rusty, but hopefully it will come back. We can only have 1 significant figure, so we need to change this number to only have 1. So it's 20 inches. And circle your answer or put a box around your answer. All right, so let's practice some conversions. Now these are just simple conversions that you should know how to do. And on number 2, they give you a relationship that you need. So at this time, pause the video so you can practice these 3 conversions, and then start the video back up again and see if you set them up correctly and if you have the right answers. Make sure you always have your calculator, something to write with, and some paper, and your periodic table. So pause the video, do these 3 conversions, and then come back and see if you are correct. Okay, so number 1, convert 23 feet to inches. Now this is similar to what we just did. So you're going to take the 23 feet and you put it in the upper left-hand corner. This unit tells you what to put down here, and that helps us set up our next conversion factor. So we're going to put feet on the bottom. It's diagonal from each other and they will cancel out. On the top, we're going to put inches because we know a relationship between feet and inches. We just used it. So 12 inches goes on top and 1 foot goes on the bottom. So now we have our problem set up, and we can see that the feet are canceling out, and then we're in inches, which is what the problem wants. So we're good. We can now calculate, which is going to be 23 times 12 divided by 1. Our feet cancel out because feet divided by feet is 1. All right, so we get 276 inches. Okay, so hopefully that is what you got. Now, if you weren't able to figure the significant figures out yet, that's okay. We can still work on that and practice on that. But if you look at 23 feet, 23 has 2 significant figures. All right, so that means our answer can only have 2 significant figures, so we need to change the 276 to 280. The 0 there is not significant, and so that's how we get 2 significant digits in our answer. All right, number 2. Convert 4,230 feet to miles. And notice the problem gives us a relationship. Now, I didn't have to do this. We can look this up in Google. We can look up relationships, and you could actually have Google convert 4,230 feet to miles, but you have to show your work. You have to show how you set it up. In chemistry, we need to see that you've set it up right and that you've got the right units lined up right, and you know which ones are canceling and what the relationships are. So in this problem, we have 4,230 feet. We're going to put that in the left corner there. And then the feet tells us what to put down here. The units tell you what to do. Don't forget about that. The units tell you what to do. Feet is going to go on the bottom. So can we go right from feet to miles? Yes, because we have this conversion factor right here. So miles is going to go on top. And then we use this relationship to tell us what numbers to put there. So we have 5,280 feet on the bottom and 1 mile on top. The feet cancel out. Then we do some math. You get 4,230 divided by 5,280. Use your calculator, and this is the number that you should get. Well, right away, I know that's way too many figures. So if we look at 4,230, that has 1, 2, 3 significant figures. So our answer can only have 3. So there we go, 0.801 miles. All right, number 3, let's convert 0.061 miles to inches. All right, so we put 0.061 in that left upper corner there, and then miles is going to go on the bottom, tells us what to do. Now, do we know a relationship that goes from miles to inches? No, we don't. But we know a relationship right here from miles to feet. So we're going to have to use that first. So we're going to put feet on the top. Where do we get our numbers? In this relationship that we already have in number 2. So the 5,280 goes next to the feet, and the 1 goes next to the mile. Miles cancels out. But notice that we're in feet right here. We're supposed to be in inches. So this is a 2-step conversion problem. In chemistry, we'll do 1-step problems and 2-step problems. And so in this situation, it is a 2-step problem. All right, so we need to add another step. So, and you let the unit tell you what to do. There's our feet, and that is going to go on the bottom. And then in this case, inches is going to go on the top because we know a relationship from feet to inches. We've already used it. So then you put your numbers in. There's 12 inches in 1 foot. And now our feet cancel out, and we are in inches, which is what the problem has asked for. And at this point, we can put everything in our calculator. So what I do, you multiply all the numbers on the top, 0.061 times 5,280 times 12. And then it's 1 on the bottom. So we're just dividing by 1, so that makes it easy. And then make sure you've got the right unit. Now, one more thing. We need to look at the significant figures. So in this number, 0.061, we have 2 significant figures, so our answer can only have 2. So we will say 3,900 inches. All right, so let's remind ourselves of some terms that we've had earlier in chemistry, but let's just kind of redefine them. An atom is the smallest part of matter, and they make up everything. Everything that we deal with every single day is made up of atoms. So you have chemistry in your life every single day. And we have what we call molecules. Molecules are a group of atoms that are bonded together, and these are in covalent compounds. They share electrons, and we talked about the term molecule being used with covalent compounds when we studied those. And so, when we're talking about different particles for different things, this is how we're going to use these terms. If we're talking about an atom, we're talking about individual elements. So we can say an atom of calcium. But let's say I'm talking about water. We don't say an atom of water. In that case, we would say a molecule of water. It is a covalent compound, so we use the term molecule. And what if we had salt? We don't say a molecule of salt. We say a formula unit of salt. And we don't say an atom of salt. So atoms are used for elements. Molecules are used for covalent compounds, and formula units are used for ionic compounds. And this becomes important because 1 mole equals 6.02 times 10 to the 23rd particles. And that particle is where we're going to put in atoms, molecules, or formula units, depending on what we are calculating for. All right, so a mole, again, we're going to define it again. And I hope you're writing notes down as you go through this PowerPoint. A mole is a number equal to the number of atoms there are in exactly 12 grams of carbon. Now you've had other definitions of a mole. I told you a mole is a unit because it is. A mole is a number, 6.02 times 10 to the 23rd, because it is. But this definition tells you how they actually calculated it. So we don't need to go into detail about that. You just need to know that a mole is a unit, just like feet or miles. And then you need to understand that a mole is equal to 6.02 times 10 to the 23rd. And that brings up this guy right here, Lorenzo Avogadro. In 1841, he figured out that you could compare compounds to each other using a common factor. And he did all these experiments and came up with Avogadro's number, which is the 6.02 times 10 to the 23rd. All right, so Avogadro's number is 6.02 times 10 to the 23rd. This is the number of atoms in exactly 12 grams of carbon. So we can say that 1 mole equals 6.02 times 10 to the 23rd atoms, or molecules, or formula units. It's going to depend on if we're talking about an element, a covalent compound, or an ionic compound. All right, so what do we do with that information? Well, it's an equality. One thing equals the other, and so we can make a conversion factor. We can actually make 2 conversion factors with it. So let's see how we do that. If I have 4 moles of calcium, how many atoms do I have? Calcium is an element, so we use the term atom. All right, so we set up our T-chart. We are going to write down 4 moles in that left-hand corner. And notice it has 2 significant figures, so our answer can only have 2 significant figures. Let the unit tell you what to do next. You're going to take this mole and we're going to put it down here so they cancel out. So we put mole on the bottom. Well, do we know a relationship between moles and atoms? Yes, we do. 1 mole equals 6.02 times 10 to the 23rd atoms. So we know that relationship. So we put atoms on the top, and we're going to have 6.02 times 10 to the 23rd on top, 1 on the bottom. Moles will cancel out. And this is where we do the math in our calculator. It's very important that you know how to enter this number right here into your calculator. Everyone has a different calculator, so you will have to learn how to do it on your calculator. And this is why it's very important to have your calculator out now. put this in your calculator right now and see if you come up with the same answer that I do. If you do not, you are not putting the number in correctly into your calculator. So we need to solve that problem. All right, so 4 times 6.02 times 10 to the 23rd equals 2.4 times 10 to the 24th atoms. Now, when you put this in your calculator, you have a number bigger than that. 4 times 6.02 times 10 to the 23rd is 2.408. That's what my calculator gave me. 2.408 times 10 to the 24th. But I can only have two significant figures because of this number, and so I had to drop the 0 and the 8, and then atoms is my unit. All right, we've already done some with molar mass, but we're just going to talk about it again in this PowerPoint. We have to calculate molar mass over and over and over when we do these calculations. So we're going to go over it again in this PowerPoint. So I can use moles to determine how many grams we have of a compound. And in order to figure out the grams, we have to figure out the molar mass. So the molar mass is the mass in grams of 1 mole of the compound. All right, so how do we find the molar mass? Molar mass of an element is equal to the mass number on the periodic table. So if we're just talking about calcium, we use the periodic table, and that number underneath there, 40.08, that's what it is. And the units are grams per mole. So when I say grams per mole, that's what this little divided line is, grams per mole. So the molar mass of calcium is 40.08 grams per mole. All right, well, what about a compound? So an element's pretty easy. We just look on the box on the periodic table, and then we have it. So to find the molar mass of a compound, just add the masses of each element involved. So if there's a subscript, we're going to multiply it by whatever that mass is. So let's look at the molar mass of chlorine. Chlorine is a diatomic molecule, and so it's Cl2. That tells me in each molecule of chlorine, there's 2 chlorines bonded together, and they share electrons. So we need to look on the periodic table and get the mass of chlorine, which is 35.45. And your periodic table should have a number very similar. Some of them have more than this number listed. Some of them round it for you, but it's pretty close. All right, so 35.45. We're going to take that and we have to multiply it by 2 because of this subscript 2 right there. So 2 times 35.45 is 70.90 grams per mole. 70.90 grams per mole. And that is our answer. All right, well, what about the molar mass of water? Here we've got 2 elements. So we have to figure out the mass of each element and then add them together. So let's calculate the molar mass of water. Hydrogen has a molar mass of 1.01. So this periodic table here has a lot of digits, but we're just going to keep 2 past the decimal there and round that 0 to 1. There's 2 of them, so 2 times 1.01 is 2.02. And then we look up oxygen. Oxygen has 15.999. In this case, we'll round it up to 16. A lot of times I just leave it at 15.99. Some periodic tables have it at 16.00. But either way, our answers will be pretty close. All right, and so we add 2.02 to 16, and you get 18.02 grams per mole. And that is the molar mass of water. So that means in 1 mole of water, there's 18.02 grams. So what do we do with that information? Well, we can make another conversion factor, which means we can do more conversion problems. So we're going to use molar mass to go from grams to moles, or we could go back from moles to grams. So how many moles are in 12 grams of magnesium chloride? So let's see how we would set this problem up. We're going to start with 12 grams and we're going to moles. And who are we talking about? We're talking about magnesium chloride. So the first thing we want to do is calculate the molar mass. So we need to become experts at doing this, and you kind of do this over to the side so you have that conversion factor. Magnesium has a mass of 24.31. Make sure you have your periodic tables out so you can see where I'm getting these numbers. 24.31 times 1, because I just have one atom of magnesium, is 24.31. Chlorine has a mass of 35.45. I multiply that by 2 and I get 70.90. And then I'm going to add those two together, which gives me 95.21. So we have 95.21 grams per mole. And here is our conversion factor. 95.21 grams over 1 mole. So now we can do our conversion. So we set up our T-chart. You're going to put 12 grams in that upper left-hand corner. You use the G here, the grams, to let you know what you're going to put on the bottom, which would be grams, and then moles goes on the top. Where do we get our numbers? From our conversion factor that we have, 95.21 grams over 1 mole. Put the numbers as they match to their units, and then we have our problem. Then our grams cancels out, so we cancel these units out. We have 12 times 1 divided by 95.21. And you should get 0.13 moles. We ended in moles, and that is what the problem was asking for. So this is a one-step conversion problem. So we'll start with one step, and then we move to 2 steps. All right, so let's look at a situation where we're going to use Avogadro's number and molar mass to go from grams all the way to atoms. So here's our question. How many atoms are in 3.5 grams of sodium? So we have 3.5 grams of sodium. That is what we're starting with. And we're going to go to atoms. That's what we're going to end up with. And who are we talking about? Sodium. So you're going to look on the periodic table for sodium so we can get the molar mass. So we set up our T-chart, and you look in your problem, and you're going to put 3.5 grams up in the upper left-hand corner. The grams there is going to show you what to write in the lower right-hand corner. And they will cancel out. And then we're going to go straight to atoms. We're actually going to skip a step and make this a one-step conversion. So we know that 1 mole is 6.02 times 10 to the 23rd atoms of sodium, and 1 mole is also 22.99 grams of sodium. So 22.99 is the grams, and then 6.02 times 10 to the 23rd is the atoms. So we cancel the grams out, and we're going to put this in our calculator and come up with the answer. So I want you to pause the video, put this in your calculator, and see if you come up with the same answer. Okay, so we're going to multiply the top numbers together, and that's the answer you would get for that. And then we divide it by 22.99. And so the answer you should have got was 9.2 times 10 to the 22nd atoms. Now, 9.2 is rounded off because we can only have 2 significant figures right there. All right, so we are going to do some practice. I'm going to have more videos doing practice with just these types of problems. So you can watch more videos so you can get a better understanding of this. And then, of course, the best way to get good at this is to practice yourself.